challenge here. And I will be the chair of this session. I'm Lin Zhifen from Taiwan University. And I will introduce today's jury. Okay? And Zhang Zhenyi 教授 from Yangming 交大. Okay. And Lin Jiehong 教授 from Military Academy. Thank you. Yang Jiahui 教授 from Hongjiao University. Lin Zhongxin from Donghai University. Okay, and then we're gonna start with the reporter. Please, the captain, please introduce your member. Introduce your member.
We are 加州好番加一开国恩 and is 陈俊浩、林松敏、那我。
Okay, thank you. Next, Stanley.
Hello everyone, we are Team Stanley and we are from Sugar Senior High School. And my name is Cody, his name is Ken, his name is Ray, his name is Luke. We are all team traders. Thank you.
Okay, review.
Hello, onboard jurists and fellow competitors. I'm the captain from Team Excelsior. My name is Du Chengkai. And this is my teammates, Wu Hanxu, Cai Yuqing, and Hou Bingqian and Lin Xingyuan. Thank you.
Okay. First, we're gonna ask the opponent to pick opponent to challenge the reporter for the problem. 1 minute.
Number 10, droplet explosion.
Okay. The reporter.
We are set.
Okay. Reporter will accept this problem number 10. So please, please write down your name on the board there. Please write down in Chinese. Okay, the reporter set the challenge and ran out the time for preparation. You can have 5 minutes, and you can start your speech too. 没有特别去看，谢谢。Okay, reporter, please start your presentation.
Okay. Hello everyone. I'm from Hello. My question is question number 10. Droplet explosion. And the question description is when a drop of water mixture is deposited on the surface of a hydrophobic liquid, the resulting drop may sometimes fragment into smaller droplets. Investigate the parameters that affect the fragment and the size of the final droplet. Okay. Okay. This is our experiment. And look, you can see the liquid is spreading. And now it's almost stop. And it is shrinking after the spray. Okay. And we need micropipette to quantification and ethanol water to make a water mixture. And blue ink is also added, which helps to see the phenomena more easily. And standard oil is hydrophobic liquid. And then it's an experiment procedure. First, adjust the alcohol and water to the required ratio and add a few drops of blue ink for easy observation. And then take a required amount and drop it into the surface of the oil. Observe the phenomena of droplet explosion and measure the diameter of droplet fragments, like the earlier video. And it's our variable. The experiments have shown that the ratio has a significant effect on droplet size, and lower the alcohol concentration, the smaller the size. In addition, we also found that the phenomenon of droplet explosion cannot be observed from the alcohol concentration of 55%. And the droplet fragment with a concentration of more than 80, the fragment becomes extremely small, difficult to observe. And here is our upper breadth. We can see that the higher the ratio is smaller the size. Right now, droplet are. And then it's a drop volume. Experiments show that the amount of droplets can also slightly affect the size of the droplet. And the more the amount, the bigger the size, but its effect isn't as big as the alcohol ratio. And that is our conclusion. In the droplet explosion, the most influential parameter is the ratio. The lower the alcohol concentration, the larger the fragment, but after a certain level, 55%, this performance cannot be observed. And the amount of droplets can also slightly affect the size of the fragment. And the more the amount, the larger the fragment, there is an upper limit. Thank you.
Okay. Next, the question of opponent to the reporter. 2 minutes.
Okay, so first the question is, do you think the liquid adhesiveness between the liquid drop and the bottom liquid affects the droplet fragment size? The liquid adhesiveness between the liquid drop and the bottom liquid affect the fragment size?
No.
Okay, next question. Can you be sure that the point you drop the droplets are all the same?
We use the
I mean,
we
yes
can sure, but we use the we try to control.
Yeah. Can you be sure that you got the same size of each droplet?
No, not very sure.
Okay, next question. Did you consider temperature of the?
Yes, we measure the temperature
I mean, did you test different temperatures?
Yes.
Okay, so next one. Can you be sure that the droplet that you drop, the inside the solute doesn't condense or something, or not uneven? The droplet that you drop is uneven. Because it's a mixture, right?
Yes, it's a mixture.
Can you be sure that it's even or not? When it's dropped.
Yeah.
Okay, so next one. Do you consider the evaporation of the droplet that you drop on the liquid? Do you consider because you use alcohol, right?
Yes.
So
yes.
there must be some evaporation when the droplet is dropped. Do you consider that? The evaporation when it's dropped.
Okay, time's up. Thank you. Next 3 minutes. The preparation of the opponent. 3 minutes.
Now didn't make sure the mixture is even.他们确定跟他们有说怎么决定是这个配合。他完全是。因为也没有 picture 的什么。也没有考，也没考。都没有问题。然后你看。 concentration and distribution。
哦，
浓度
的那个
对
有没有层面？
对。
你就我们接下来的 discussion 对不对？对，你要把这 discussion 完之后，我来讲。不，其实讲好，不是先讲之后再给他说。我忘记了。啊，可以，我们先聊。
Okay, 3 minutes off. The opponent takes the floor.
Okay, so hello everyone. Hello everyone. I'm the opponent from Team Stanley. Today I'm gonna talk about the reporter. Now this is the review of the reporter, and it has clear shown footage that the color is very obvious.
Could you please louder?
Oh, okay. First, you got a very obvious color, and it's clearly shown in the footage, and you got good experiment equipment. And the contents are you got shaking footage, and second, you didn't show the data clear enough because it's too far from here, and we cannot see the detailed number of each one. And third one, not enough theory to explain the data. The fourth one didn't consider temperature as a variable for a lack of parameters and different variables. And these are the questions that I asked. And the last one I didn't have enough time to ask. And first one is liquid adhesiveness between the liquid drop and the bottom liquid. And the point the droplets drop, the same size of the droplet, temperature and solitude evenness. When solitude evenness means it's talking about the droplet evenness. And the next one is evaporation. And the answer for the first question is no. And you didn't consider that next page. And the point that the droplet drops, and you cannot be sure that each time you drop you drop at the same point or not. And you cannot be sure that you have the same size of droplet. And temperature, you didn't consider that as a variable. And you cannot be sure the solitude evenness. And you didn't consider evaporation too. And I think that's a big factor of this experiment because the fragmentation, after the fragmentation of the droplet, the evaporation will be more aggressive. So I think that is a thing that you have to be improved. Okay, and that's all. Okay. And here's the discussion part. Okay, so first, can you deviate different mechanism of different droplets that you drop? I mean, like, the question means, can you tell me, like, can you draw a picture or show us how the droplet expand or fragment in different droplets, and you can draw. link how is working. Oh yes, I did. And you have to
and because of the surface tension and it is alcohol and other alcohol and water. Okay. And other is water. And water's action surface temperature is bigger than the mixture. And it will that mixture to like this, and it will become it will change to this, and it spreads.
Oh, it spreads. So how about like different portion of the droplet? Like this you show in the spread, right?
Because of the percent difference and
the gas is bigger or smaller? I mean,
if your picture is if your
do you mean tension? Surface tension?
If your surface tension is bigger like water, it will more prefer to be like a
oh, bigger droplet to spread. You mean like the mechanism is like just higher portion of alcohol in the droplet, and the droplet that will fragment is bigger because of the tension. You mean like that? So higher. Okay, you can show me. You can show me.
The lower is bigger.
Okay, next discussion, we're going to talk about the purpose of choosing the liquid mixture for the droplet. Because I think when we are doing some research about this topic, there are other experiments that use different alcohols. Yeah, so what is the purpose of this kind of more operative characteristic of
We want to discuss the different percentage.
No, it's the purpose of using this mixture, alcohol and water. Why not other kind of alcohols?
Because the surface feature is different, and alcohol is good mixing from the water and with the water.
Okay, next explain. Is there any relationship between these choices? Is that like why we choose like the gap between each droplet is 5%? Why don't you consider it's like 10% or something else? Or like the maximum proportion is 90%? Yeah, what? Is there any relationship? Like why do you choose this and the relationship between these that you choose as a purpose?
No, we just say use 5%.
You don't use okay, so will the fragmentation because of hydrophobic instead of surface tension? That means that when you drop it, and this is the oil, right? And you drop it on the liquid, and then it is all because of the hydrophobicity. Yeah, and that spreads the mixture of alcohol and water. And instead, it's not the reason that it spreads is not about the surface tension.
Oh, it drops and you will become like this shape.
But I mean the reason. Would there be a possibility that the hydrophobicity effect has a greater factor? Is a greater factor than the surface tension that you mentioned before? Will that be a possibility, or is that a yes or a no? What do you think?
Surface. What you use the surface is not very important because it's just a thing to that is
spray.
Okay, so but why is not important? If you drop it on this, and the surface tension depends on the liquid that you drop on. I mean, you can have a different kind of oil, and if you try different kind of oil, and you know the surface tension for each kind of liquid that you drop on, maybe that can show the answer for this question. Okay, next one. And can you use your theory to predict the phenomenon of different alcohols? And that means different alcohols. That means different length of the carbon chain.
Different alcohol is not affect.
So do you try or just?
Yes, we try, but we don't. This picture is from the alcohol.
Yeah, but
And other liquid is simple about is a similar with similar to this.
okay, and I want to ask you another question. Did you try to observe the little fragments? I mean, like little fragments. You can see that the sizes are different. But did you try to observe it?
Yes.
Can you show the relationship? Because we can see it from there, too far away. The fragment concentration. So, can you tell more about this? And the scale you use, the scale.
This is the diameter about the circle. The dropping.
It's a whole diameter. Okay, so
it's a final diameter. It's spray and final is become a little drop.
fragments. So these are
The fragments diameter.
Okay, so can you explain to me why? Show me the. Yes. Can you tell me why that these fragments are much bigger than this one? Can you tell me your theory or?
No, it's just a photo.
I mean from the edges, like you can see obviously there is 60% portion.
Our picture is not picture when the final situation. It's middle of it. It's a percent.
Can you answer again? I mean, I have the little fragments. Can you tell me why or what do you think about or your imagination? Like, why does the edges of the fragment are different? The sizes of the fragment are different. Yeah, like here and 60%.
Because of the your echo mixture the water and different liquid has different surface feature.
Okay, so show me the diameter. So yes. So is there? So do you think that there must be a portion of between the alcohol water mixture and the diameter of your droplet? Do you think there's a portion between it or not? Yes. In the relationship, what do you think the relationship is? Is it
I think
exponential or?
The more percent of the alcohol will have a smaller diameter.
You mean diameter of the?
Yeah, diameter.
Okay. And the last discussion we're gonna talk about is like viscosity effects on the final droplet. So that means some kind of liquid is easily to get close to with oil, and some doesn't. So do you think that variable affects your final diameter? Or you can talk about like
Maybe because of the theory is the friction surface feature.
Okay, and the next one I'm gonna ask you is, do you think there's a limitation between limitation of the mixture and the oil that you drop?
Yes,
Because
because
there's some relationship or like.
limit, like the value.
No, I mean like you cannot have a too high a portion of alcohol. Like you cannot, if you are 90% of portion, you cannot see anything.
I cannot see that.
So you didn't do it, or you just get there.
Because it can.
Okay, this is the end of the discussion. Next, the opponent will summarize the discussion for the next 1 minute.
Okay. Okay, so the first question, they didn't know the mechanism of different droplets that you drop on. And the second one is they didn't have a clear purpose of choosing this liquid mixture for the droplet. They just think a random. And third one, is there a relationship between these choices? No, they didn't have it. They just see the experiment and try to And the fourth one is, will the fragmentation be because of hydrophobicity instead of surface tension? I think they mostly did researches on the surface tension and they did not consider the hydrophobicity. And they didn't have a theory to predict the phenomenon of the alcohols. And I'm sorry, they have a typo here. And they didn't have a.
Thank you. Time's up. Next, the reviewer will ask the question for the next 3 minutes.
For both of you.
Reporter?
For the reporter.
Please stand up.
For the reporter, how do you think the volume and the concentration of the alcohol will affect the results, such as its size and its shape? How will the volume and the concentration affect the final droplet? It will make it bigger or smaller or something.
If the alcohol more the volume, if it is higher, the volume is smaller.
It will evaporate faster, so have the stronger surface tension. I mean X or. Okay, I have a question for the opponents. That how do you think so? How will the volume and the concentration affect the results?
The volume and concentration, you mean the droplet?
Yes, the volume and the concentration of the droplets that affect the results.
Okay. First, if you have a bigger droplet, the more energy, the more potential energy you get from when you drop it, and I think that will make the.
Okay, thank you.
Okay.
Okay, for the reporter, what factors do you think will cause the deviation of the result? Like temperature, humidity, or
The temperature and the
okay, thank you. For both of you, what is the difference? Okay, for the reporter first. What is the difference of the elements inside the mother droplets, in the droplets and the final droplets? What are their difference?
Because it is.
I mean, you have dropped the droplet onto the surface of oil, and it is a drop, and after it evaporates, it will have the smaller droplets. And what are the difference of them?
They are almost different, but the alcohol will spray in the air. Almost the same.
So for both of you, opponent first. Did you reporter first? Sorry. Did you consider how the thickness of the hydrophobic liquid affects the result of the experiment? Thank you. I would like to go to the next question. Due to your report, why when the concentration increase will the maximum radius increase? Can you explain that?
Time's up. Okay.
Okay, thank you.
Next 2 minutes. Preparation of the reviewer. Okay, reviewer takes the floor for the next 4 minutes.
Hello, honorable jurists and fellow competitors. I'm the reviewer from King Associate, and I'm going to review the problem number 10, droplet explosion. This is a problem statement. When a drop of a water mixture is deposited on the surface of a hydrophobic liquid, the resulting drop may sometimes fragment into smaller droplets. Investigate the parameters that affect the fragmentation and the size of the final droplets. And my main focus will be what causes the phenomenon to happen and how do different parameters affect the phenomenon. And for the reporter, there has the clear observation and the phenomenon for the fragmentation. So it has the clear observation of the droplet explosion, but there has lack of theory to describe the fragmentation, which the theory is unclear, and they didn't consider the effect of the fragmentation. And with this experiment, they do the parameters of the alcohol ratio and the droplet volume. So they have some parameters which will affect the fragmentation. But they have lack of the physics explanation behind the fragmentation, lack of the parameters that and measure it. Like a thickness of oil, the syringe releasing height and the surface tension. And for the opponents, when they are discussing the summary, they discuss about the initial condition about the droplets and the evaporation effects in the droplet explosion. And they did great about they asked about how will the surface tension affect the experiment, and they gave their own opinions about the reason that caused the explosion. But they didn't consider the viscosity effect of the oil, which means that the hydrophobic liquid may cause the result of the explosion different. And didn't consider and then didn't give the personal input about why would have the fragmentation. They have discussed about the opponent asked how will the droplet explode, and the reporter said that it was because of surface tension. And the reviewer believes that the water mixture evaporation will cause the surface tension difference, which and the droplet will try to tend to the lower surface energy and change its shape, then will eject into smaller droplets. And next, they discuss about the water mixture, like why the reporter used alcohol, and reporter says that it is good mixed with the water. The reviewer disagreed with the reporter. The reviewer believes that it was because the alcohol water mixture will evaporate faster, so it will be easy to observe and analyze the experimental results. And they discuss about the liquid. The one asked that how will the hydrophobic liquid affect the result of the experiment, and the reporter say no, it didn't affect. But the reviewer believes that it will affect the maximum radius and the explosion time and size of the final droplet, which means that the viscosity effect will affect the final the result of the experiment. And they also discussed about the size of the final droplets, that the opponent asked that why is the size of the final droplet different, and reporter answered that the surface tension difference. And the reviewer will believes that it will affect the evaporation rate, and that's the final droplet size be bigger or smaller. And these are the point missing. They has missed about the quantitative explanation of the maximum radius, the ejection of the small droplets, boundary condition of the fragmentation, and it didn't explain the concentration difference on the model droplets. And they lack important parameters like viscosity, surface tension of the oil. And they didn't have definition of the model droplets, smaller droplets, and the final size of droplet and fragmentation. and they have
Thank you. Hands up.
and they are considered.
Okay.
Important.
We will have concluding remarks from the reporter. 2 minutes.
We use this method. Reason is we use a code because it can mix with water perfectly, and its percentage is smaller than water, so we can see mixtures in different surface intention. And the reason, the question of the temperature, we do this experiment at the same time and we'll measure it before every experiment. And also we need to ensure that water alcohol ratio is the same as first. That's all.
All right. Thank you. Next will be the question from the jury. Any professor has questions?
Okay. I will have a question for a report. When you measure this droplet size, did you take the same time, or do you consider time dependent? Because the size distribution is.
Yeah, we do it at the same time.
So what is your conclusion?
In the droplet explosion, it's the most influential parameter is the ratio. The lower alcohol concentration, the larger the fragment.
Doesn't depend on time. The size, the final size doesn't depend on the time.
And it's almost stop, but not actually.
Okay.
Do you have any question for the reviewer and opponent too? The same question?
Yeah, so the same question. Do you think the time of the observation is important?
Me?
Yeah.
Oh, I think because we didn't do this experiment, but we did some research. Is that if you drop it and you last, if you made a droplet last a long time, I think the small droplet will start to combine with each other. Yes, and I think that's my imagination of the result of time. If the time is long, the outer fragment droplet will start to combine with each other and become a little bigger droplet, but if the time is short, the fragment will still be a fragment. Yes.
So how do you think the optimized size, optimized time?
I didn't know the actual version of the time and the droplet size, but I only know the trend, the main trend of it. Like when time's longer, the fragment will combine with each other and become bigger. And the shorter the time, and you just drop it and you measure it, immediately the droplet will still be a fragment. Yes.
So for the reviewer, the same question: how do you model this?
You mean how to
The effect of time.
how about the time effect?
Yeah.
The first question will be if the time went along, the liquid the mixture will evaporate, so it will evaporate and the final droplet will become smaller. But to investigate the size of the final droplet, it needs to be measured instantly. So we think the time that you measured, or you measure that the size, or you measure the final the result of the experiment will be important to the experiment.
Any questions from our jury?
Okay, so do you think the small fragment is water only, or is mixture of water and alcohol? What do you think? Yeah, for because.
At the moment that the small droplets fragment to the small droplet from the droplets from the big droplets, it will has a critical concentration which cause the droplets to exchange. But after the surface tension of the oil ball is out, it will continue to evaporate. So the size will be more and more small after the time passes.
So in your experiment, you find the size smaller?
At first, when it's injected, it has water and alcohol.
Yeah.
But at the end, it only has it only has the water in the droplet.
So how do you think?
It's matter about both of them. Maybe the final we can see, and it will only water.
And I think that when the time goes by and because the surface area has gone bigger, not just the droplet, so the alcohol will begin to evaporate and the water droplet will be left on the oil, and I think maybe the water droplet will start to combine with each other, like has gone a bigger droplet, like a little droplet of water and will on the surface of oil, they will start to goes together and form a bigger droplet. Yeah, as the time goes by, yes.
Okay. Any questions? No. Okay. Thank you. So now the juries will have the score. If you are down, please raise your hand and bring it on with them. Thank you. Okay, right now we have the score for the reporter. 4, 4, 6, 5, 6. Okay, thank you. Now for the opponent. 6, 5, 7, 6, 7. Okay. Now the score for the reviewer. 7, 7, 8, 7, 8. Okay. Thank you very much. We will have 5 minutes break, please. Change the equipment in the location. The location, 第二回合你们是 review， 嘉义中学是 review。
对，就这样，那明天也交给你。对，讲起来了。你坐这里。
现在第3题有增加。对不起，应该跟中央，现在第3题有增加。还有干什么？这一题可以敲这一如果说完全没有做，应该把你我
对，我也是这次的，我也是这次的。我前面已经有方案了，我就直接这次我要靠。因为做这个谁的，他跑去之后就没有就算你讲他应该是因为我那个上面才讲，我看你应该不太了解。对啊，因为我们在甩锅啊，我也不太了解，因为我们在甩锅。这一题你说带卡，对，学生不可以凶人。可是我要教。等下决定，如果他们不在，然后接下来。
那你们这场讲就是先不管，你们这场比较有痛。
你们想要问
不会，没有让你说。我们想3个。
现在说啊，反正不会是最低分，
就是我们待会挑战一下。
不会是最低分的，
尽量讲。
应该是有7分。
8分7分就3.9。就去那个带的这个300有哪些？
你现在赶快做8分7分。这样他说我们在打，不是啊，刚刚我们要就是我们要挑战。
其实都是这样的。
已经出来了，那个细微。Wait a minute. 哦，OK。
如果可以的话，
对对对。是。
上面OK， 不是，就是我们没办法好太复杂，我们上面就是
你们觉得怎么样？
应该谢谢你，
你们会更惨的，
就换我上面。
May I try to another?
我现在让我干，然后我报告。
这我的笔吗？不是吧？这是吗？
你前一天没有洗完头，没有吹头发就回来睡觉，是不是有时候感冒什么？
对。
我已经准备好了，就是那个week全部都先打说，implement as a program。真的不能那个。
But the time is.
仙女情缘，仙女情缘，冰雪情缘。可以上来这边，可以上来这边。电，这才能多找一个。我觉得我不知道这边。对啊，今天2个高三应该都他没有，他们去参加什么原住民？
Okay, please have a seat. Okay, we're gonna start the stage 2 of this S602, okay? We will have the opponent challenge the reporter for the problem. 1 minute. Hands up.
We want to turn to number problem 15. Boycott the fact.
They reject from 15.
We want to try problem number 2, really disk.
Reject.
拒绝2次，对，第3次不会拒绝。第3次，第4次啊，这是我们扣分。可以拒绝3次扣分，3次不会被扣分，然后第4次到4跟5会被扣分，然后5次之后一定要接受。扣分。带进来不要。
We tried number 14, 4 on November.
All set, all set.
Please write down the member name on the board.赖宏斌写错位置是不是？
然后干嘛？我怕写错，对不起。
这个可以把时间稍，这个可以把时间稍微加回去。
好，这个可以加到
Pause for 10 seconds， 暂停15秒。Okay, time starts to run, okay? 5 minutes, I mean, you still. Reporter, please start your presentation.
Okay, so hello everyone. I'm the reporter from Typt. Today my topic is ball on membrane, and here's a problem statement. When dropping a metal ball on a rubber membrane stretched over a plastic cup, the cell can be hurt. Explain the origin of the cell and explore how its characteristics depend on relevant parameters. So with filamental first, origin of cells and characteristics depends on relevant parameters. And here's our table of content that we're going to report. First, the introduction is about the differences between cell and the origin of the cell. And second, we'll introduce our experiment design. And third, we'll have an analysis of our experimental data. And fourth, we'll conclude the whole report and organize the flaws and detail that we can. And then why the sound? Sound is a result of being vibrating and sending energy through a medium. The specific sound in this experiment is an impact sound, which is caused by things colliding with each other. And this causes the air pressure to raise and create a sound that can be heard by others. The sound characteristics for this experiment are volume, frequency, and time between each sound being produced. And here's my experiment. I'll take more time. Okay. So this is how the experiment works. You just drop a ball above the membrane, then the ball will bounce on top of the membrane and create sounds. And as you can see in the video, in the experiment we use electric spot as a membrane and fastening with a rubber band, and we choose 12.5 centimeters to drop the ball. And the ball gets pulled down from its original state or height by gravitational force. While it was pulled down from its original state, it gained kinetic energy and lost potential energy. The product of both kinetic energy changes into elastic energy and gets bounced off the surface. And when the membrane stretches to a critical point, the membrane releases its potential energy by changing it into kinetic energy. Okay, so while releasing the electric energy of the membrane, air pressure around the membrane will be created, which causes sound.
And this is our experiment data. As you can see, this is a big ball and middle ball and a small ball. And these are frequency that we record. The x-axis x-axis is a frequency, and the y-axis is the decibel. And the reason that the decibel is negative is because the sound is depart from many sound, many frequency of the sound, and each frequency of sound has its decibel, so it's departed, so it's negative. And this is a big ball of the data. And next, this is a mid ball of the data, and this is small ball of data. And as you can see, these charts are similar, but in a specific sound, it has some differences. As you can see, in the peak, in the next page, it has a curve. Yes. Okay, so. And these are our improvement. First, the sound may not be recorded forward, so there might be some other independent variable not discovered. Second, because of the result of our experiment, we found that the tension of the membrane can change during the experiment. But in this part, we use a rubber band, and we draw a line on the rubber band. So if it is changed, we can see it. So I think this part is not obvious. So the characteristic of sound may change during the experiment. Thank you for the presentation.
Question, opponent to the reporter. 2 minutes.
Okay. Is the sound you heard caused by the air vibration?
Yes, air vibration.
Okay. Will the vibration of membrane cause the air vibration?
Yes.
Okay, thank you. Is the ball collision causing the membrane to vibrate?
What?
When the ball hits the membrane, yes, right? Will the ball cause the membrane to vibrate?
Cause the membrane? Yes.
Okay, thank you. Well, every time the sound you heard from the membrane will be the same. Each time you drop the ball, will every time the sound you heard be the same?
No, because
okay, thank you. Will the wave speed be constant during your experiment?
The wave speed.
The wave speed of the membrane.
Or the wave speed of the membrane.
Will it be constant?
Will be constant.
It will be constant. Yes. Okay, thank you. Will there be standing wave on the edge of your cup? Will there be the amplitude? Will there be amplitude in the edge of your cup?
No.
Okay. Do you think the wave on the membrane can transform energy?
Yes.
Okay. Please turn to your experiment, the FFT. Yes, this one.
This one.
Why will there be a specific peak right here?
Why will there be?
Is this peak generated by the air or the vibration of the membrane?
Yes.
Is this caused by the vibration of the membrane? Okay. Will the intensity of the sound affect by the height where you release the ball? Okay. What caused the sound that you can be heard?
What caused the sound?
Yes.
Air vibration.
Okay, thank you.
All right, time's up. Thank you. Next 3 minutes. Preparation of the opponent.
No serious connect with no serious connect. No.
你一直抄我是没有上的，你抄干就好。
没关系。
The opponent take the floor.
Hello, honorable judges and competitors. I'm from Team Excelsior, and today what I'm going to oppose is problem number 14, ball and membrane. This is a problem statement. When dropping a metal ball on a rubber membrane stretched over a plastic cup, a sound can be heard. Explain the origin of the sound and explore how the characteristics depends on the relevant parameters. And what I'm going to main focus is investigate the origin of sound and how does the collision of the ball affect the membrane to vibrate, and how do the characteristics of the membrane affect the sound intensity and frequency. This is my structure of solving a problem. First, I will investigate the origin of the sound, and I want to discuss about why will there be some specific peak in the graph the reporter shows, and will there be a boundary condition. And then I want to discuss about the conduct experiment about the collision of the ball and the characteristic of the membrane's vibration. Such like, will the shape of the membrane affect the characteristics of membrane's vibration, and will the wave speed also affect? And some parameters such like size of the membrane and the placement of ball. It means where you collide your ball with the membrane will affect the characteristics of the sound. And finally, I'll analyze the characteristics of the sound, including the sound intensity and the frequency. Here's the reporter's pros and cons. First, the reporter did good on clear observation video about how a ball on the membrane collides, but didn't explain and he tried to explain why would there have sound when the ball hits the membrane. But the reporter doesn't explain why there will be resonance by the theory, and doesn't measure the tension of the membrane, because I think I want to discuss about will the tension of the membrane will affect the sound, and doesn't show the density of the membrane. And the opponent also think this will affect the sound characteristics and not well explain the experiment error and not well explain how parameters affect the experiment result and lack of parameter. This is my point to be discussed. First, I would like to discuss about the origin of the sound. First, about the air vibration. We want to know if the sound could be heard, what will the air vibration will affect, and the boundary condition. We want to know if the standing wave on the edge of the cup will have amplitude and will the frequency be amplified, and will the shape of the membrane affect the boundary condition. And for the amplified frequency, we want to know if the frequency could be able to predict, and will it fit with the Bessel function or it is sine wave of your membrane. And next one moves to the next part, the membrane's vibration. When you collide with your, like the short question answer, when you collide your ball with the membrane, the sound could be heard. So we want to know that if the shape of the membrane and the wave speed, size of the membrane, and the placement of the ball is affected by the collision of the ball. And will there be a resonance frequency that can be heard? It means the specific peak that is very loud. And for the deformation, will the ball collide with your membrane cause deformation? And the characteristics of the sound about the fast Fourier transform and transition of the energy. Will the frequency be affected by the Bessel function, collision of the ball, amplified frequency, and the sound intensity? We want to know the relationship between the frequency and the sound intensity.
Okay, recorder.
Okay, as you mentioned in your short question, you said there will be no vibration on the edge of the cup. Can you explain why?
Because we control we didn't hit the edge, but I mean I just control the ball on the membrane.
Yeah, so when the membrane starts vibrating, right? You agree that the membrane will vibrate? Yes. The vibration on the edge of the cup, will there be amplitude? Will the standing wave there vibrating?
Well, sending wave.
Yes, the standing wave. Will standing wave vibrate at the edge of the cup?
Oh, sorry, I'll choose my answer. Yes.
Okay. The opponent thinks that there will be no amplitude at the edge of the cup because when the standing wave reach the edge of the cup, it will be stuck by the edge of the cup and which won't vibrate. And please turn to your experiment. In the audacity, the graph like this one, yes, this one. Why will there be different frequency be amplified?
Will be different frequency.
Yes, why will there be different frequency?
Because there. You mean the three picture of the data, right?
The picture here, this shows that this frequency is about like 190 hertz. But for this one, this looks like it reached 500 hertz. Can you explain why will you hear different frequency of the sound?
Of course, this data is combined with many frequencies.
Yes.
It's just separated.
Okay, thank you. Well, what do you think? Why will it cause so many frequencies? What's the physics behind it? What's the physics reason behind it?
Physics. Because the sound is caused by a complex.
Can you explain it by your theory?
No.
No. The opponent thinks that it is caused by the boundary condition of the cup. When the cup, we need to fix the wave equation, which is when the wave fits the wave equation and also fits the boundary condition, it will have the resonance of the frequency. Thank you.
Sorry, can you show me the theory?
Can I use the backward?
Sure.
The wave equation looks like this. when it is a square membrane, which is the x and y axis?
Yes.
Excuse me. Oh. Okay, man. This is the wave equation, and when you consider the boundary condition of your cup, which and this is the wave equation. When your wave need to fit the boundary condition, it means when the standing wave is at the top of the membrane, it won't vibrate. So it has many solutions to fit the U versus the wave to describe the vibration directly. So when substitute that thing into this wave equation fits, it will have different frequency.
So what's your definition of this formula?
This formula.
Air resonance.
Yes, this will cause air resonance because while the wave fits the wave equation, it will have sound. Thank you. Can you control your frequency to different frequency? I mean, what will change the frequency of the sound instead of that? Yes.
I think it's the elastic coefficient.
Oh, do you measure it?
I don't know how to measure it.
Oh, you said it's, so you mean it's important to consider it, but you didn't do it.
Yes.
Okay. The opponent thinks that you should consider it because the medium of the membrane will affect the wave speed, which the wave speed will affect the frequency of the membrane. Thank you.
Daniel, as you typed on the report, and it has a side of membrane, and it also can change the elastic coefficient.
Okay, got it. Please turn to your observation video. Please show the video. When you drop your ball on your membrane, right?
Yes.
Will the ball cause the membrane to deform? Will the ball cause the deformation to the membrane?
It depends, but not at all.
It's not at all. Can you prove it by your experiment data?
But we didn't record that.
Okay. Please, no. Do you consider the fast Fourier transform? By doing this method, you can. Do you consider fast Fourier transform?
No.
Oh, the opponent thinks that if using this method, you can know that each sound will have, as you mentioned in your answer, you said this is a complicated, vibration. So I think you should consider the fast Fourier transform in your experiment. And please turn to the experiment.
Sorry, can you write it down?
Please turn to your experiment.
All the fast Fourier transform.
You have it in your report. You know. Okay, never mind.
I might.
Well, the size of the membrane.
Never mind.
Do you agree that the size of the membrane will affect the frequency?
Yes. As I mentioned before, the size of the membrane will change the elastic coefficient.
So in different shape of the membrane, it will. If you can control the tension of the membrane in each part the same, then will the shape of the cup affect your sound?
Okay.
If today the size of the cup is square, will it affect the amplified frequency? As you mentioned, you said it's a complicated frequency.
is possible to make a square? Is it not possible to make a square membrane? The tension will not be predicted. And tension is not uneven.
The opponent thinks that if you can measure the tension by using if you control 3 parts for example, if you can control 3 parts of the membrane to elongation to be the same, then you can pull a side of the membrane and to pull, and you can know the tension of it. And if the elongation is the same.
So you mean measure the 3 point of the tension?
Control the 3 sides of the membrane, then pull one side of membrane by tension meter. Then if the elongation is the same, you can know that each point of the membrane, the tension of each part of membrane will be the same.
There's some angle.
Okay. What do you think will affect the sound intensity?
Sorry?
What do you think will affect the sound intensity?
Well, what affect?
The volume. The volume of the sound. Yes. What will affect the sound volume?
Oh, I think the volume is not associated with the frequency.
Okay. Please turn to experiment.
This is the experiment.
This observation. The graph. The graph.
The purple
one. Yeah. The purple one. The purple one. Yes. As you see in this graph, there is a different intensity of each.
Thank you. Time's up.
Why will that be different?
Time's up. Opponent, I'll summarize discussion in 1 minute. 1 minute. Okay, you start.
Okay. We have discussed about the origin of the sound, knowing that the sound is caused by the air vibration, so it could be heard. And we have discussed about the boundary condition and the edge of the curve, but that wave equation can prove that it will affect the origin of the sound. And we have discussed the membrane vibration, and the size of the membrane will affect the membrane's vibration. And some specific frequency could be amplified, like this graph shows. And the experiment, we have discussed about the deformation caused will there be deformation caused by a ball? And the reporter answered, it's not important to consider it. And the characteristic of the sound, we have not done discussing about the sound intensity of the experiment. Thank you.
Okay, reviewer, please. You have 3 minutes.
So I want to add that you have made the experiment and shown that it will cause the various of frequencies, yes?
Because due to the wave equation, any wave, if fits the wave equation, will have some specific vibrating motion.
And I want to ask the reporter, have you ever record? Yes, because I just see the one data, and I want to ask you that, have you do this experiment for many times?
For many times? Yes, we do. We have 3. We have big, middle, and small.
Why use this? Why choose this? Why choose? Why did you choose the big one?
The big one. Which
So
is different mass of the ball.
So you choose. So
The mass will, I mean the mass will affect the photon energy. So we choose different. The mass is a factor of power extraction.
And I want to ask the after. Yes. You just say that you think the left vibration will spread to the edge of the
Yes.
And how can you sure?
How can I be sure that will happen? because when you give the membrane energy from the ball collision, it causes the membrane want to vibrate in every direction when it fits the wave equation. So it will, when it collides with the membrane, it will cause the whole membrane to vibrate, except from the edge of the cup.
Sorry, that's question. Are you sure that the height of the ball folder?
Sorry.
Do I have? I want to see. Yes. So, what did you choose this?
If I choose so small, the bottom membrane causes sound is so too low, so
you choose this.
Just height of it.
Thanks. I have no any question.
Okay. Right now we have 2 minutes for the preparation of the review. Okay, reviewer, please take the floor. 4 minutes.
So I'm going to review the reporter and argument statement. The purpose statement is, the main focus is to find the origin of this sound and how it's going to depend on relevant parameters. And it's a summary of the reporter. They say the gravity gives the ball kinetic energy, and it transforms the elastic energy of the membrane when it hits the membrane. And then the vibration causes the air waves and make the sound. And question 1 is, vibration may spread to the edge of the cup, but the reporter says that it's not considered. And the question 2 is, when the wave sends to the cup, it may make sounds in different frequencies. And the opponent, they give a useful suggestion to the reporter. But the reporter thinks that the result from the expanding situation of the membrane, not knowing how to measure it. And so it's the comment of the reporters. I think they speak in they didn't speak too fast because I can hear clearly. And then but the cause is that they did not mention how many times that, yes, or how to explain? I mean, they say they do 3 times of experiments, but I think each one should do more times, and then they didn't consider enough situation. Here is the comments of opponent. List point clearly and provide useful suggestion. The cost is just that they speak too fluently so that I can catch. I think it's prone. I don't know, so but. For me, so here is a missing point that they didn't consider the humidity or temperature and other that affect the sound velocity of the air, because in this environment there are many parameters that may influence this experiment, and then maybe you can consider to do the experiment about sound and the falling height, because you say when your height is not too high, the sound is not so loud. But I think you can try to find the relation of the height and the sound. Thanks, is my review.
Okay. Next will be for the reporter to make the concluding remarks. Takes 2 minutes. 2 minutes.
So, at the discussion part, the opponent said that the wave sent to the edge, that it will stop. The wave will stop. But when the reviewer will ask the opponent, but he changed his answer, so it didn't unclear to show us what is changing. He didn't define the equation clearly. Okay, so I still have some improvement. I didn't consider all the factors that in our experiment, and I think that the square of the membrane is impossible to make. I mean the uniform membrane, because you can't have the uniform tension of the membrane in a square shape, because of the circle membrane of the same radius, and the square membrane has an angle, so it's uneven. Yes, that's all my remarks.
Okay, thank you. Okay, next, any question from the jury? Okay,
Opponent. Okay, you mentioned about the FFT in your PPT.
Yes.
Yes. What is FFT?
FFT is fast Fourier transform, and it could transform a complicated wave and display it into the origin wave that is when it's the origin wave.
But in this experiment, what the relation between this relation and
because,
the FFT?
Because as the reporter mentioned, this is a complicated wave, right? So we can use the FFT to know that the origin wave, and each origin wave will have a specific sound and a specific frequency and intensity.
Okay, second, you mentioned about the Bessel function, right? Yes. What's the Bessel function?
Bessel function is to, may I use the backboard?
Yes.
We define the function when changing this one into the coordinate axis, which will look like this. substitute this into and for example, this is the circle membrane. From the center of it reaching out, this will the distance to this is r, and the angle to every position is set up to represent the coordinate axis. So when substitute this, the boundary condition is like this. When the r equals to the radius of the cup and relative to setup in the t will equals to 0. It means the standing wave at the edge of the cup will be 0. And by solving the math, by doing math, it means the solving equation, we can get and where
Good.
that's a function.
Okay, any questions from the okay. Since the operator is so active, I would like to ask one more question.
Yeah, sure.
You mentioned here your Laplace here only have 2 dimensions.
Yes, that is for just for the, but there is square membrane. If the reporter can consider about the circle membrane, it will transform into the Laplacian about the coordinate work.
But I'm thinking you have a cup. It has the depth. So obviously there is a 3rd dimension.
3rd dimension.
Hey, why don't you consider that part?
Because I don't know.
How about the other 2? The other how about the reporter? Have you considered the 3rd dimension?
I don't even understand what you.
Okay, how about the reviewer?
Actually, I just didn't know how to because how to calculate it.
Okay. Okay. Any questions? Okay,
Do you think the sound velocity of the air is the key parameter in this experience?
The sound.
The velocity of sound in air.
No.
What do you think? I think you just mentioned that they have to consider this term, right?
I think yes. Actually, I think because in different situations, you can see the because the man. So the environment is the environment in different situations. The speed of the voice is different.
So is this the key parameter in this experience?
Sorry, I don't think it affects a lot.
But you said that they should consider this term, right?
I think the question is sorry, but the situation will influence the condition of the lead rubber member. So I think if you didn't control it in the same environment, you will have the different parameter of the rubber member.
Oh, the voice speed will affect it will not mainly it will not mainly affect the sound frequency, but when it is the frequency of air we can see at 2L divided by NV, which the V is the wave speed, and N equals to 1 and 2 and 3. So in some circumstances the air frequency will be resonance. So it could
Resonance of what?
Resonance of the sound generated from the membrane.
Membrane?
The membrane. Yeah.
Okay. All right. So right now the jury case I have the score. You all have the score right now. Okay. Good. Right now the grade for the reporter. Okay. 5, 5, 5, 5, 7. Okay. Now next for the opponent. 8, 8, 8, 7, 9.
Thank you.
Okay, and then for the reviewer. Okay. 6, 5, 5, 5, 6. Okay. Thank you, everybody. We will have a recess for 10 minutes.
冷气无法强一点，爆掉了。冷气的那个，完整的谁都知道，全部都是高端范围。可是我烂的，可是我烂，连表面张力也是高端。表面张力很难，我都不会。表面张力很难。你看电吧，帮我拿下包包。他们是reporter 其实没有太多机会。我最清楚的还是我还是要问啊。对啊。而且你就会听他讲，然后听他讲没有，不会按听我说这样子。所以这个我是有备稿的，因为我原本是比较期待别人这样没有可能很老讲。上位，知道我那个多一个那种怕吵，我们那个已经破坏那样子。反正因为他应该是打算自己讲，他应该是打算自己讲，他就想绕看啊，他打算就是打算绕看。当然有啊，当然这是常见的，全程就是要然后最主要的那个。有种发现，还要写，要公司的话。好了。
要另外
不用写公式吧？
家的不同。
我可背不起来啊。那公式应该说我的板书很丑，就是没有办法。我没有语吧？对啊。
你可以查。
读怪物。读怪物。
讲那个
这类我那个上来是可以看到我的实验书。
我要讲那
显然是生活天气才有它。
你要上厕所吗？要上时间去？没有。我们差不多3点，对，差不多4点。学习在下面就早1个半小时。
跟8手的现在。
我差不多1个半小时啊。
那以前还可以这种比较大。水的这里接近应该是大。
昨天的，而且表弟上昨天，然后我们记得
没有，如果你把每一个那个
原则上我们都是尽量就是针对他的来讲。昨天晚上有很多 report 来讲，需要想要把那些东西加在那个，这样用混的方式。如果这样做，就是他的报告，然后我们什么？这是我现在会做很大的，因为我在因为他自己的资讯到状况下，我应该就是我问的时候他答不出来，就是要引导他带领他，我们就会出现，就会看到这个应该。
那我们先不要出现了。没有，我们先不要出现，我们死定了。
哦。
got the point。这个叫做 G 的那个吗？
那我要先把我不能简报看一下。
可以选。
你那准备简报我看
什么？模板弄好了？
模板弄好了。对哦，之前对。
我刚是临时被叫说要去抢这个。
高度。
你看我连里面该砍的都不掉。
就是它的力量。这样告诉我
就是你他那个叫什么？他指的那个，就是好的系列图。他那个图是也分析啊，我是想考考问题，你知道复利这个？
那你这个我有。
你这个东西就要复利的，这个东西不知道。
这呢？啊，算了，还是这个。
对，
那就等下再说啊，反正可以加跟加证明。可以加可以加证明计时。
可是我觉得等一下我们的题不太多，这个时间我觉得
实验室没什么要他就好好做，他就好好做，他就会挑起来。
如果对方听不懂的话，
对方听不懂，可以下下他们。就很不同重量的球。
对啊，为什么要不同？应该是有不同张力。
那个应该是因为说位能会不一样，重力位。
那你觉得会不会有很大的？
是影响应该会影响在声波的这里。
正因为肯定是它的容量，这是对它的回应。
可是如果正不够小的话，它就有可能是它确实就有可能传不到那个。
没办法激发的。那你来的你在被激发的时候就不是动力。会影响它的频率的应该是那个东西的张力。
张力啊，而且它张的时候，它的张力也不一定准。
所以你要想到尽量变张力，
第四个。
你们要放分布哦。
那个实验就难在要让张力均匀。
不管经不经营，就是你要试图去改变它。
试图去控制，
试试看。
是让这个对对对。
这很多高中东西解决不出来。
没关系啦，大家讲好了，大家都好，大家都好。
我还是我跟红光城电脑还是。
他还不是老师吗？他就会我去当做比赛好了，当那种会试比赛。
我们现在剩4题啊。
30、80，好，这边。 已经写上去了。
对，没有，你应该开啊。
对啊，我开了几个啊，第一把写进来是。
没有啊，我看看我7期然后配报告啊。
7期，因为你现在6题可以选，7期然后6题可以选。
但是我现在很多学校有这个坏习惯。
那明天有我还可以带。
没了，其他学校我不敢乱讲，学校这个选项很麻烦。
因为我们还没有报告到在之后。
对。
我们刚报告了，都会从
先是要那个中断，
钱开始多。
如果学生愿意玩这一套，那可能中断了传承。
对啊，我们讲完那个之后啊。
冷气有没有办法调整？
没有，我们机想那个3面3可能体会一下，没有3面3两个，但是然后最后一场呢，它是全部都可以调整，只要你没报告过都可以调，我们就开始调。
在货币来。
然后呢，所以我们每次干。所以今天晚上把3面3都会有。我们来互相采购。
我们的那个这2个问题。
你用看的打，对啊。当然不是了，因为我不是啊，没有就是多。哦，这是英式英文 ，CNTR。没有，是英式英文，英式英文，我感觉一下。
不是为什么？
它是英式拼法啊，你有办法啊？
对啊。Okay, we will have our final stage, and the first we will have opponent to challenge the reporter. Problems.
We would like to challenge number 4.
Number 4. Opponent? Okay, now reporter has 5 minutes to prepare. And please write down your number. The name of the member, report. Review. Standing. Standing says review. Please write down the name.
找一些啊，都在3啊，这样比较快。就是认识我同事把优点跟缺点都写啊，之后呢再试图用砍掉其中一边啊，砍掉比用打得快。我就最近很痴呆，怎么办？我最近开始少年痴呆症。然后我就晚上去订东西的时候，我找钥匙找的。我是不知道白领领域的那个，啊算了，就不要听就好了。你用中文好了，好了，你用中文写好了。我是觉得写的会比较快。
Hello, the honorable jurists and fellow competitors. I'm the reporter from Team Excelsior. Now I'm going to report problem number 4, unsinkable disk. Problem statement. A metal disk with a hole at its center sinks into a bottom sink in a container filled with the water. And when a vertical water jet hits the center of the disk, it may float on the water surface. And explain this phenomenon and investigate the relevant parameters. And we are mainly focused on what is the reason that caused the metal disk to floating on the water surface, and how the relevant parameter affect the unsinkable situation. This is my reporter outline. First, I will have the preliminary experiments about show the observation video and have some phenomenon explanation. And in a theory part, I will have calculation of the wafer number and have some first analysis and calculation of the critical value of the flow velocity. And in the experiment part, I will do some parameters and then discuss some possible error. And in the end, I will have the conclusion. First is the preliminary experiment. As you can see the observation video, when we put the metal disk on the water surface without the water jet hitting on it, then it may sink into a bottom. But when the water jet hits on a metal disk and it can float on the water surface, it means that it is an unsinkable situation. But when we close the water, it still sticks to the bottom. And about the phenomenon explanation is that by the Bernoulli principles, when the water jet hits on a metal disk, so you will have the flow velocity on the disk. And when the flow velocity on the top of the disk is higher than on the bottom of the disk, it will cause the pressure difference. So which is the lifting force support the metal disk to floating on the water surface. And about the theory, this is our theoretical assumption. We assume that it's an ideal fluid which is incompressible and no shear modulus and neglects the viscosity. And about first the calculation of the Weber number. we calculate the wave number around the hole, and we know that we analyze that the wave number will higher than 1, so we can ignore the surface tension effect around the hole. And this is the first analysis of the metal disc. First, you will have when the water jet hits on the metal disc, you will have a water impulsive force. And also, the mass of the disc and the mass of the water on the disc, you have the gravitational force, which is the downward force. And also, you have the upward force, including the surface tension, lifting force. And also, the main reason is that pressure difference force that cause the metal disc has an unsinkable situation. And in order to find out the mass of the water on the disc, so we need to analyze the thickness variety depends on the x and y axis. After we track and analyze this, and we'll find that the thickness of the water on the disc will be inversely proportional with the distance to the edge of the hole. So we assume a fitting constant k to build our theoretical model. And via our experiment, we got this value. And this is the calculation of the mass on the disc. And you have a gravitational force is about the downward force. And this is the calculation of the pressure difference. The pressure difference will include the height difference and also the flow velocity difference. And when this kind of pressure is acting on the cross-section area of the metal disc, so you will have upward force that the paper spiral will have an unsinkable, let the metal disc will have an unsinkable situation. And this is when the metal disc has the unsinkable situation, which means that the force will be balanced. And so we expand the formula and calculate the critical value of the flow velocity, which will let the metal disc has the unsinkable situation. And this is our experiment. About the experiment equipment, we use the water pipe to catch the water from the faucet. And then we try let our water tank to be more bigger because that it can reduce the effect of when the water jet hits the bottom of the water tank or the side of the water tank and cause the additional flow. And we also have the metal disc and the flow meter, which we use to measure the flow volume rate and transfer into the flow velocity. This is our experimental setup, as we try to adjust the flow velocity that's hitting on the metal disc and try to find out approximately value which will let the metal disc to be unsinkable. And this is the first experiment about the mass of the disc. As you can see, the mass of the disc will be positive correlation to the critical value of the flow velocities. And it was because that when the mass of the disc increases, which will let the gravitational force to increases. So it needs a bigger pressure difference and lifting the metal disc. So when the force is balanced, so the critical value of the flow velocity will increases. And this is about the experiment about the radius of the disc. We make sure that the mass of the disc is the same even if we change the radius of the disc. And this is the experiment result. As you can see, the radius of the disc will be negative correlation to the critical value of the flow velocities. It was because that when we increase the radius of the disc, then the cross-section area of the metal disc will increases. So when the same value of the pressure difference acting on the bigger cross-section area, so you will have a bigger force to let to lifting the metal disc. So we did not need such higher initial flow velocity. And then this is the experiment about the radius of the hole. As you can see, the radius of the hole will be positive correlation to the critical value of the flow velocities. Then this phenomenon will affect by two reasons. First one is that when the radius of the hole increases, which lets the cross-section area of the metal disc decrease. So when the same value pressure difference acting on a smaller cross-section area, so it needs a higher initial flow velocities. And another reason is that when the radius of the hole increases, means that when the water jet hits on the metal disc, and the water left on the metal disc will will decreases. So which means that it will decrease the flow velocities that flow in on the disk. So in the end, so you need the initial flow velocity to be higher. And this is the experiment about the cross-section area of the water flow. We change the radius of the water pipe and do this experiment. As you can see, the experiment result, the cross-section area of the flow will be negative correlation to a critical value of the flow velocities. Then it was because that when the cross-section of the water flow increases, then when the water jet hits on the metal disc, then the water left on the metal disc will increases, which will produce the bigger flow velocities than on the metal disc. So it doesn't need such higher initial velocity. And then it's our discussion. First discussion is about the possible error condition. When the flow volume rate is very higher, then we observe that you will cause some bubbles, and which will affect the disk and also affect the flow. So you have the possibility to cause the experimental error. And this is the second condition, is that when the flow volume rate is very smaller, we observe that the deviation of the cross-section area of the flow will be increases. So when due to the continuity equation, when the deviation of the cross-section area of the water flow increases, also the deviation of the flow velocity will increases too, which also have the possibility to cause the experimental error in our experiment. And this is the special situation, is that when the metal disc without the hole, then it still, as you can see the video, it still can float on the water surface. It was because that the main cause the metal disc to float is because of the pressure difference. So when the water jet hit on the metal disc, it causes the flow velocity difference, and in the end, it will have the pressure difference lifting the metal disc. So due to our theory, that you can see that, and when the radius of the hole is 0, we still have the critical value of the flow velocity that can have the unsinkable situation. So we think that the function of the hole is to stabilize the disc to let it will not shake or another movement. And about the conclusion, this phenomenon will happen was because that when the water jet hit on the metal disc, it will cause the flow velocities difference. And so the flow velocities difference due to the Bernoulli principle, it will cause a pressure difference too. And so when the pressure difference acting on the cross-section area of the metal disc will have a lifting force to cause an unsinkable situation. And so due to our full analysis, we can calculate the critical value of the flow velocity, which can let the metal disc to have an unsinkable situation. And this is our experiment. First is the mass. These parameters will affect the gravitational force of the disc, and so need to increase the flow velocities and increase the pressure difference. And another parameter is radius of the hole. This will affect by the flow velocity on the disc and also the cross-section area of the disc. As you can see, without the hole, it still can float. As I mentioned in our discussion. And about the radius of the disc, you will affect the cross-section area of the disc, and so you will let the pressure difference acting on the disc, and we can decrease the initial flow velocities. And about the cross-section area of the water flow, and this will let the water left on the metal disc to increases, which will cause the bigger flow velocity on the disc. So we need such higher initial flow velocities. And this is our discussion about some possible error in this experiment. When the flow velocity is too high or too low, it maybe will have the bubble or the deviation of the cross-section area, so cause the deviation. And this is my report. Thank you.
Okay, good. Next question of the opponent to the reporter, 2 minutes.
Could you please show your conclusion
start again. The flow velocity you showed, you means the flow below the disk or above the disk?
I think we means that is the flow velocity of the water jet that hitting on the metal disc.
The water jet?
Yes. Because that the flow velocity on the disc will because that when the water jet hitting on the disc, so it will have the let the water to like this direction. So this flow velocity will cause the flow velocity difference. So this is our main discussed in our experiments. There's the critical value of the water flow velocity of the water jet will let the metal disc have the unsinkable situation.
Did you find that maybe there's a fast flow velocity to make the disc flow?
Fast?
The fast velocity.
This means that as you can see the charge, when we increase the flow velocities, and it will increases the pressure difference. So which may also let the metal disc to have the unsinkable situation.
So is there a fast flow velocity for this flow?
We discussed is about the critical value. Means that the value that just let the metal disc to be unsinkable. Okay. And sorry, do you want to ask about if you will have the flow convection below the metal disc?
Okay, time's up. Next 3 minutes will be the preparation time for the corner.
这个人在吗？
Okay, your opponent, please take the floor.
Okay, and I'm going to oppose this question. First, about problem statement. The main problem I want to discuss is about the metal disc with a hole. But in your experiment, you also observe that maybe the disc without the hole. I think it's an interesting question, but I think it's a little bit not fit the problem. And first, I'm going to summarize your theory. You mentioned permanent principles, which is related to the difference between the fluid velocity above and below. And you also mentioned the thickness of the water above the metal disc, which would result to the difference of the pressures below and above the disc. And you also mentioned that smaller radius of the hole on the disc, the less water goes through the hole. And about the experiments, you do many experiments, which including changing the mass or changing the radius of the hole and changing the radius of water pipe. And you also mentioned that something may make the experience error, like bubbles or something. And about your conclusion is that smaller the hole is, so the watershed is right? Then you also mentioned that the watershed velocity is too high or too low won't allow the disc to flow. And here's some suggestions from me. But your advantage, I think you give your clear opinion, and so I can understand your opinion clearly. And about suggestions, I think you should consider what problem are asking more. That is asking the disc with a hole, but so you should put more time on absorbing the disc with hole, not absorbing the disc without a hole. And that's all. I'll take questions in the discussion part.
Okay. Okay, go ahead.
In this question part, your first question is that, could you please show me the page that your result, your experiment result?
Do you want to
The chart.
okay? So what is want to ask? Do you want to ask is the x and a circle means?
I know the circle and the cross mean, and there's some distance between the circle and cross for the lines, right? And what do you think the distance means?
This is the value that we measure. The value will this will have unthinkable or thinkable situation. This is the value that we can control in our measurement. And it was because that this critical value in our experiment, we only can find the approximate value. So this experiment result is just an approximate value. So still we use the method to try to decreases a little bit the flow velocity. Also we show that it is a unthinkable situation or not. And then if it can be unthinkable, then we decreases the flow velocities and do the experiment. So when the value got got the critical value, then you will, under the critical value velocity, then you may have the sinkable situation.
So it means the bubble may make the possibility of unsinkable situation.
Oh, about the bubbles is that we think that some special condition that it may cause the experimental error. It's like that when the bubbles that it will happen that when the flow velocity that is very big. So you can see these pictures. Maybe you have some bubbles that in the you have some bubbles in the flow, right? So the bubbles will have the affect the this and also affect the flow. So maybe you have cause some experimental error.
You have mentioned the Bernoulli's principle, right?
Yes, yes.
And you observe the disk without hole, right? And
the disk without hole condition is some special. So before this condition, all of our experiment is about the disk at the hole in the center.
Okay.
Yes, it's just a discussion in part. And
I think the disk without a hole won't be affected by the Bernoulli principle.
Because that the reporter thinks that when the water jet hits on the, may I use the blackboard?
Sure.
And this is the metal deck surface, and there will be a lot of water. So when a vertical water jet hits on the disk, even if it have the hole like this, so partial water will into the container, and some of the water will flowing on the metal disc like this. Yes. So this will have a flow velocities. So and we think that because that our container is very big, so in our theory we assume that the layer will not have the flow velocities. So this value and this value will have the flow velocity difference and cause the pressure difference, which is like when the flow velocity difference will have the pressure difference. That is, it means that this point pressures.
So the velocity you consider is the velocity above the disk and below the disk.
This is the deviation between. It is the difference between the on the disk and on the top and on the bottom. Yes.
And maybe you have tried to use the container not that deep, so that you can have.
Did you mention that the situation is that when maybe the container is not such depth, so maybe this water will hit the bottom, so it will have some additional flow. So we think that it will cause some experimental error because this is not our theory to describe this situation.
And could I see the page of your formula?
Okay. This.
Yeah. Yes. And which theory does this formula based on?
This is as you can see, it's by the bonus principle. It's called the pressure difference, and this part is the height difference that causes the pressure difference, and this part is the flow velocity difference. So totally the pressure difference, and this the pressure difference of the metal disc.
Okay, and have you ever considered that maybe when the radius of the water gets bigger than the radius of the hole?
Do you want to ask about the boundary condition of the crossing radius of the?
Have you ever considered when the radius of the water jet
is bigger than the radius of the hole.
Yes, this phenomenon will happen is always is that the radius of the water flow is bigger than the radius of the hole. Because that when the radius of the hole is smaller, then all the water will be into a container. So without
the flow on the water, without water above the disk, and there won't be difference of pressure.
Yes.
Okay. And could I see the picture of the force again?
Do you want to add the force map? Oh. Here.
Did you consider the surface tension?
Yes, as you can see, and around the disk, you have a surface tension to lifting the disk. But if you in the hole around the hole, the surface tension in our calculation of the Weber's number. And so we can, when it is higher than 1, so we can ignore the effect of the surface tension around this part. But we also have calculate the surface tension effect on the around the disk.
I think you know that. You know the water just hit the disk, right?
Yes.
So the disk will be pushed down.
Yes.
And then the water surface will be like this. And here's the line. That's main pressure difference.
But due to our observation is that the water will be like this. So this is the metal disk. On this part will not affect the pressures that are acting on the metal disk.
How do you sure that it won't affect on the metal disk?
And this is the we think that we due to our theoretical model and due to the experiment, and it is fit the experiment, it fit the field. So maybe you will have a little bit effect, but I think reporter think that you will not affect a lot.
Which experiments shows that it won't affect the most?
It's like all the parameters we did when the situation is the theory when we didn't consider this part. So all the experiment is to result can prove it.
Okay, I understand your opinion.
Thank you.
Okay. The opponent summarized the discussion. Are you done? Yeah. Okay. Opponent summarize. 1 minute.
We talked about the theory he based on to build the formula and his experiment. And I think most of his formula and experiments are based on the theory correctly. I think it's a good report.
That's it? Okay, thank you. Okay, next, the reviewer asks a question. The next 3 minutes.
Okay, so the first question I want to ask is for the opponent.
Reviewer.
Okay. So wait, where's the? I think. Hold up, sorry. You did ask about the flow velocity that they show in the picture, right? And he answered you that the flow velocity is the water above the disk. Is that correct?
Yes.
So what was your purpose of asking the question?
I think the flow velocity is associated with the Bernoulli principle.
The second question is for the reporter. I want to ask what makes you want to try if this without a hole? will happen this unthinkable situations?
Because we want to prove that the main reason that caused this phenomenon happen. Because it was because that when it is like a flow convection under the metal disc, so when it without the hole, so you will not have the air will not have the flow convection under the yes. So we want to prove that it's caused by the pressure difference.
Okay. And okay, this question for the reporter. You did mention about this, but I want to listen to your answers again about how do you make sure the weights near the disk will not affect the final result of your experiment?
Because that when this is the this part of the weight is not under the metal disc. And so also the pressure difference is under the metal disc and acting on a less cross-section area.
Okay.
So it will not affect.
But wouldn't the weight be transferred to the disc? It goes like to the disc?
Because do you mean this weight is when the critical flow velocity is not such higher to let the metal disc to be unsinkable. So then you will sink to the bottom. Then the weight the water will stick on the metal disc.
Okay, I get that. Can you go to your experiment pages, which includes a chart and some formulas?
Okay.
You can change. You might have to update that. I'm asking to move the presentation.
Time's up. Time's up.
Excuse me, I still have a question that was delayed by the delay of the presentation showing.
I think time's up. Okay, let's move forward. Okay, next 2 minutes. You can put that in your conclusion. Okay, 2 minutes to prepare for the review. Okay, the reviewer takes the floor for the next 4 minutes.
Honorable judges and fellow opponents, today I'll be reviewing the previous section about unsinkable disk. Right, let's go. So I will not repeat the problem statement since I believe all of you has already understand the problem statement. So first for the reporters, their pros, I believe, is that they have a very detailed calculations, and they did try different. They did consider all kinds of different variables in their experiment, and also they even tried the disk without the hole. Well, they tried if this kind of disk will happen this situation from the topic. I believe this is really good, and also they make a clear definition of their own theory. Some cons that can be improved is that they didn't mention a lot about why, sorry, that's a typo right there, why the experiment is a little bit different from the theory. In every single theory and experiment data comparing chart, which was my question that fails to be answered. And also, sometimes during the discussion part, they will interrupt the opponent. I believe that it is because they have the form answer and a form question from the opponent. So I believe that will sometimes interrupt the question that opponent wanted to ask. Also, they sometimes misunderstand the question of the opponent, which is what I mentioned. They have a form question and a form answer inside of them. So they did misunderstand a lot of questions from the opponent. And for the opponent, your pros are that you did focus on the theory in their report, and you have a lot of suggesting questions for their experiment. And they all did to successfully to answer your questions. Some cons is that when you're doing your presentations, the words on your presentation was really hard to see. And also, I believe when you're asking the questions, you should be a little bit more aggressive so that the question you want to ask can be solved. Okay. So during their discussion, this is all the questions that have discussed about. The opponent asked about, did you find the best velocity to float the disk? And I believe this is one of the questions that failed to be answered by the reporter, since they just turned on to another unrelatable question that has nothing to do with the opponent's question. So I didn't type the response of the reporter. Next is the opponent's question is, what's the flow velocity you show in the previous picture? And the response of the reporter says that it's a velocity of the water above the disk, on the disk. And also next page, sorry. Next page. Opponent's questions about if the water jet is bigger than the hole, will this situation still happen? The response of the reporter is that this topic only happens when the hole is bigger than the water jet. I believe this could be mentioned in the previous experiment. Next page, thank you. Now for a discussion, the opponent asked about how to make sure the waves near the disk will not affect the result. This is the question I previously just asked, and he did give me a clear answer and tell me why this won't happen. So this is something to be encouraged. And I believe that is all of my review for this session. Thank you.
Thank you. Okay. Okay, reporter, what are the concluding remarks for the next 2 minutes?
Hello, this is my concluding remark. First, that the phenomenon will happen is because that the flow velocity difference that when the water jet hit on the metal disc, and so it will cause the pressure difference due to the photovoltaic principle. And we did some we used some photovoltaic principle to build our theoretical model, and we do some experiments about the mass and the radius of the hole and the radius of the disc, and also the cross-section area of the flow. And then in the end, we discuss some possible error may cause a deviation from the theory line. And about the remarks, first, that we assert that the disk without the hole in order is to know that the main reason that caused the metal disk to have an unsinkable disk is because of the pressure difference. It's not the underforce like the flow convection under the metal disk or the other. So we did this discussion. And about the we consider the flow velocity difference in our theory and also in a phenomenon explanation. And about the opponent asked some question about the container that if it is not a dead inert, then we reduce this condition happen So you will not have some additional flow that you will acting on the metal disk and affect the experiment results. And the question that the opponent asked is that the boundary calculation is about when the radius of the flow is always bigger than the radius of the hole. And so reportedly that this is the condition that we do the experiment and we are mainly focused on about, because only this will cause the flow velocity difference and also the pressure difference. And about reviewer questions about so this is my concluding remark. Thank you.
Okay, thank you. Please, following review. We will have the question from the jury. So please.
We have a question. In your experiment, the flow rate is a very important parameter. How do you control your flow rate? You said I didn't notice. How do you control your flow rate?
We adjust the flow rates by the flow volume rates of the faucet, and we measure that. You have a flow meter to measure that and transfer into the flow velocity.
But it's just outside your faucet, or the flow rates are just outside your faucet, or it's tip on your disk?
I believe that we also did use some measuring. Is that we use the cup, and it is and we analyze that the time how long that you got a value of the water, so we can calculate the flow volume rate.
But when you convert that into the flow rate, when we keep the disk surface, you should consider this gravitational force with acceleration between its depth in your faucet and your disk. Did you consider that?
Do means that because that you have the deviation, so you have the gravitational force.
I mean the flow rate just outside your faucet is different when it's hit the disk, right?
We measure that we not only use the flow meter, we also measure that use the cup, and we measure the flow volume rate. So this is the flow velocity that hitting on the metal disk. And we also try to reduce the distance between the outlet and the metal disk, so it will not affect by the gravitational force and have some acceleration.
Probably it didn't explain it very easily. Yeah.
Question?
So the question for you. So you say that you just consider water jet is bigger than the hole, right? And so even there is no hole there, the disk will not unsink. But because the question is that there is a hole in the center, so the hole should be a key point of this question. So why didn't you do the experiment that the jet big smaller than the hole? Maybe that it will still make the disk unsink. Did you do that?
Yes, we have did this experiment is when the radius of the flow is smaller than the radius of the disk, and so it will depend on the surface tension and the buoyancy of the disk. Will not have the pressure difference.
But I think that maybe that's the real question. Not this question I want to ask you. If the jet is small, jet size is smaller than the hole, and then you don't need to consider the flow on the disk. You just consider the flow under the water and the gravitational force.
Because
that's the question. There are questions.
Okay.
How do you think?
Because that due to our observation that when it will have some flow convection under the metal disk, it's because that when you will have the bubble and driving the flow to hit on the metal disk. So it is not the flow just it is produced by the bubble.
But you just try to use a flow rate that will not create bubble. You can use a flow rate that will not create bubble. you can use this condition without bubble under the air. So under water. Okay, how do you think if the how if the hole is larger than the jet?
Is what?
The whole size is larger than the jet size.
Larger than the jet.
Yeah. How do you think that?
I think it will still be able to float, right?
Yeah.
Yeah. But wait. First,
It's all right.
How do you answer?
No, I think when the radius of the water jet is smaller than this, I think this will still happen. The water higher than this will still be made, and so I think there is still possibility for it to float, for it to float.
Okay. Thank you.
Okay, any questions? Okay, no? All right, thank you. So now, the jury has agreed. Okay, first, the next down is the recorder. Okay, it's 8, 9, 8, 8, 8. Okay, 8, 9, 8, 8. Okay, now for the opponent. For the opponent, 6, 6, 6, 5, 6. For the reviewer, you can show. Okay. 7, 7, 7, 6, 7. All right, thank you very much. Thank you for all the participants. And this is the end of the stage.